Good evening, everyone. This is Obi-Wan Pez for Simplex Pachinko. Tonight we're going to be doing a bit, yet again, bit of mathematics within Calc 2. Again, we're just trying to look at like getting a first draft of everything that I'm trying to teach in this fall, and see if we can't come up with something a little bit cooler than maybe what the book has. It's a little bit hard without an interactive class, but hey, I think it's worth giving it a shot. So. Alright, so this is an application problem that comes from this book that I'm using. Again, this is OpenStax Calc 2. Calculus Volume 2. So if anybody else wants to follow along, feel free. And if anybody else is coming in here and wants questions on something else, please interrupt me because this is perfectly fine. Alright. So the base of a lamp is being constructed by taking a quarter of a circle, y equals the square root of 2x minus x squared, rotated about the y-axis from x is going to go between 1 and 2. So whereas we have our y-axis here, this is x equals 0. We have x equals 2 over here, and x equals 1 here. So the actual shape itself is rotated about, or the actual shape itself is made up of this quarter circle, which goes from x equals 1 to x equals 2. And then this creates a hole in the center of our lampshade here. Sorry, not lamp shade, lamp base. It's like the bottom of the lamp around the bottom. The weighted part, if you will. So if we want to have some sort of like enamel paint that's on this, or who knows, I mean, we can come up with any scenario you want. And again, what we want to be able to do is to paint or color or whatever this base of the lamp that goes all the way around. So, all the way around. So for this, we would want to do the same surface area integral that we talked about before, which was that we can take the line integral, figure out what the distance of this line is, or the arc length of this particular curve. And then once we do that, we can then rotate it around the entire axis here. Now, in order to do so, all right. So without looking, this is always the fun part, right? So without looking at the integral formula, we should be able to create this thing and build it out from what we have here. So the distance along this curve, right, the arc length, is going to be integral from a to b of the square root 1 plus parentheses f prime at x squared dx. So again, what we're really looking at here is that the dr distance along the curve itself is going to be made up by a component of, well, dr squared, I guess, is going to be made up of the component distances of dx squared and dy squared. So that means that dr is just going to be the square root of this whole thing. And also, we can factor out a dx from all these terms. Dx squared. That becomes 1 plus dy dx parentheses squared. And dx squared, we take the square root. Dr is going to be equal to the square root of 1 plus parentheses dy dx squared times dx on the outside. Alright, so dy dx is f prime of x. We square that whole thing once we get it. And that's going to get us one individual dr portion, and then we want to take the integral over the entire a to b region. In this case, it's x going from 1 to 2. Alright, then, in order to get all of the surface of this thing, we need to figure out what the circumference is of all of these individual pieces. This is going to be 2 pi times r. And r is going to be defined by the individual locations of all these points. So, oops. That was interesting. And not what I meant. Okay. Right, okay. So this goes back to, this wasn't actually the circumference that we're looking at. This is going to be, what is the area of the frustrum of a cone? This is going to be broke up into frustra. So here we... Okay, and in this particular case, let's see, is it really going that way? No, because it's going around this way. It's got to be... Yeah, right. So since we're going to do this infinitesimal frustrum in this direction, we do have to talk about this in terms of a function g of y, which is going to be defined by our original function, which is a function of x. So we have to reverse everything in the first place. So if f of x is equal to the square root of 2x minus x squared, then we can say here that we want something easily invertible. Still so hot in this room. Okay. I mean, what else am I expecting, right? So if I do a +1 minus 1, we're going to get a negative here, and then this is going to be x squared minus, nope, whoa, x minus 1, parentheses squared. And then this minus 1 here is going to have a negative applied to it, so it's going to be plus 1. Or square root of 1 minus parentheses x minus 1 squared. This can be a potentially could be a u substitution. Well, we don't need it. Never mind. Yeah, because if this is just equal to y, now it's invertible. Alright, cool. So we're going to square both sides, so we got y squared is equal to all this stuff. Right, you got to remember your goal as you're going through this. My goal here was to have one x term, not actually to take its integral or anything like that. So it's going to be 1 minus parentheses x minus 1 squared. If we want to solve for x, we want this term to be positive, so flip which one this is. This is going to be 1 minus y squared. This is going to be x minus 1 parentheses squared. And now we're going to take the square root of both sides. This is the absolute value of x minus 1 is equal to the square root of 1 minus y squared. And we only want the top half. So the distance between 1 and x is only going to be positive anyway. Right, x is going to be greater than 1. So this is going to be positive. If we just have it be x minus 1, this is square root of 1 minus y squared. This is x equals 1 plus square root 1 minus y squared. Alright, surface area for this whole frustrum process here is going to be integral x, nope, it's y. Y goes from 0 to 1. Of, so we get 2 pi times the function itself, which is going to be g of y equals 1 plus square root 1 minus y squared. Times the square root of 1 plus, and here we want the derivative of this thing, g prime of y is going to be equal to, this is going to take down, this is 1 half, parentheses 1 minus y squared raised to the negative 1 half, multiplied by the derivative of the inside is going to be a negative 2y. It's going to be a negative 1, so it's half of 2, and then we get a y on top and a square root of 1 minus y squared at the bottom. That's g prime. Okay, and then g prime of y block squared is going to be equal to y squared divided by 1 minus y squared. This looks suspicious. So 1 plus y squared over 1 minus y squared is going to make 1 minus y squared plus y squared. That's what I wanted. Divided by 1 minus y squared. Those two things are going to add out. How are we doing? Doing well. Alright. So those two things will subtract out. We get 0 here. We get just 1 over. Oops. That's not that. So 1 over, I can't see that. 1 over 1 minus y squared. It's going to be equal to the 1 plus parentheses g prime of y squared term that we had there. So this whole integral here is going to end up becoming the square root of 1 over 1 minus y squared. And we're going to get on the outside 1 plus the square root of 1 minus y squared. And integral times 2 pi dy. All right. This is going to end up becoming just the original integral that we had here. So the integral of 1 over 1 minus y squared. And then this one here is going to end up multiplying into the top. So the square root and the square root can not quite factor, but they have common exponents now, so these two pieces are absorbed in with each other. This is multiplied to the top, 1 minus y squared divided by 1 minus y squared that was already there. So that's just 1. Times of dy. I have a feeling that's like an arc sign or something that I'm not remembering. Yep, arc sign. Cool. So this is going to be 2 pi times parentheses arc sign of y plus y evaluated where y goes from 0 to 1. Awesome. Alright. So then this is going to be 2 pi times arc sign 1 minus arc sign 0 plus 1 minus 0 for the y. Alright, arc sign of 1 is going to be 90 degrees or pi over 2. Arc sign of 0 is going to be 0. So this is going to be equal to a pi squared plus 2 pi. So the surface area of this thing is pi squared plus 2 pi, which is, real quick, pi squared plus very approximately 16.15 square units. Alright, so this is how you can calculate surface area. Again, you're going to use a arc length integral to get the distance along the curve itself, and then that is multiplied by the function itself times the 2 pi that you had originally. In this particular case, we had to trade f of x into g of y because we were looking at something that was revolved around the y-axis. So in terms of the y-axis, you got to have something that's in you got to have something that uses our function of y, a function of y, when it's rotated around the y-axis. So unlike disk washer or shell methods, which you can do either as long as it works out in the end, this one, again, because you're doing an infinitesimal frustrum as your piece, as your infinitesimal piece, then it really needs to be oriented in the correct direction. Alright, so another application that will definitely be asked of students is what would happen if you had an inanimate carbon rod. I'll show you inanimate. So you have an inanimate rod of some kind, and you want to figure out what the mass of this object is. If you know, for instance, that there is some sort of density function, which is determined by some function rho of x, which allows you to define the density of that object along its length. Then again, this sort of becomes trivial once you know how unit analysis works. So, and you do have to know some calculus at least, but you know. So if we take some sort of coin out of this, like a sliver of this particular object, then what we can do is look at what is the mass and how is it defined in terms of calculations. Well, mass is going to be volume times density. If you don't know that, that's okay. Since you do know some sort of density function, generally speaking, they're going to give you the units that are used in it, so like kilograms per cubic meter, or cubic centimeter, or grams per cubic centimeter, or something like that. They'll give you some information about it. So in this particular case, let's just do